maximum sum circular subarray, where we are given with an array and we need to calculate the maximum sum in a subarray. So if we just remove this word, then it's quite simple. We just gonna traverse the array. Here 1 is the maximum till now, and at this point still the 1, still the 1, still the 1, but here it's 3. But if we consider circular, then it should be moving to the first element again to form the circle. So 3 plus 1, then it should be 4. So without circle, so that means we don't have those elements at the edge. So then the pseudocode is quite simple. We just have two variables, maxsum and the local sum, with the first element of an array. So we're gonna loop this array starting from the second element, and we're gonna calculate local sum in each iteration, which is a maximum of current element and the local sum plus current element. So the local sum basically till the time we have that sum, and at any point if we see that maximum sum is lesser than the local sum, then we're gonna assign local sum into maximum sum, and at the end of the loop we're gonna return maximum sum. As per the pseudocode, here is a local sum and the maximum sum. I was just taking abbreviation for the local and the maximum, L and M. So at the first point we have L as a first element, M as a first element, and starting from the second element, that main index is a 1. So at the second step we will have L, which is 1, plus minus 2, which is minus 1. So what is the maximum, minus 1 or minus 2? It's minus 1. So minus 1, and the maximum is still 1 because we need to compare here. If maximum is lesser than the L, then it will be changed, otherwise it will be the same. So at the second point we have minus 1 and 1. So 1 plus minus 1 is 0, but the current element is bigger than that, so I will have 1. So here still 1. At the second point we have 1 plus minus 1, which is 0. So 0 or minus 1. So 0 is greater, so it is 0, and then it is still 1. So our answer is 1. So now circular array example, I just added another one element, which is 3. So following the same process as above, our steps will be like this. So now maximum sum is 3. So answer is 3. But it should be 4, right? Because it should be like 3 and going to 1 and the 4. Okay, so with circle, if we calculate the total sum of all the elements in the array, and then subtract the maximum subarray who are not contributing to form the maximum sum in circular array, then we're gonna get the sum of edge elements if they are maximum. So our pseudocode will calculate the maximum sum. So we're gonna invert all the element from this array to this array. So 1 is minus 1, minus 2 is 2, and similar other elements. And we're gonna calculate the maximum sum subarray of this array and then subtracting from the total sum. So if you add all the elements in this array, so you will get the total sum 2, and the inverted array is this, just inverting every elements. So following the same process as we did above, so we will get this. So here maximum sum is 2 and the total sum is 2. So what we're gonna do is 2, which is total sum, minus the maximum sum, which is 2. We are doing a negation here because we already inverted the elements, so that's why. So the answer is 4. So we got the answer. So let's jump into the code. So here, taking the same array, and we're gonna calculate that pseudocode as a actual code which gonna return the maximum sum of subarray here. This is without the circle, and then we are calculating total sum by adding all the elements and then inverting the array. So we have array which is inverted now at this point, and so we're gonna call the same function again. So it's gonna return maximum sum of subarray which are not contributing for circular, and after that we're just subtracting it from total sum. So at the last step we are just doing the maximum of without circle and with circle, because it is possible that that is not forming a circle. So in that case we're gonna return the normal maximum sum of subarray. So that's it. Thanks for watching, and please like, share and subscribe if you like the video.